Hello. So we are on. This is chapter 6, and we're going to look at circles in this chapter. And so what we're going to start off with is looking at midpoints and perpendicular bisectors. Now, firstly, midpoints. Okay. So last time we looked at straight lines and the line connecting 2 points, say this point here and this point at the end there. Okay, so two ends of a line, we call that, say, x1 y1 and x2 y2, and we looked at find perhaps the gradient and the equation of the line, and then we looked at if they're perpendicular or not and stuff like that. And actually what else you can do with this line is to work out what's in the middle, which should be about there, right? This middle point here, and we call this the midpoint, obviously, because it's the middle point. And this will be useful to us in a moment. But how to calculate it? Well, it's the middle point, I guess. So it's the average value. So in the middle, and so we calculate the midpoint by doing, well, it's the average of the x values and the y values. So the average or mean average, right, you add the values together and then divide by how many there are. Well, we have x1 and x2, so we have the two x values over 2 because there's two of them, and that's the average x value, which should give me the middle x point. Then likewise for the y coordinate, the middle y point would be the adding those two together, y1 and y2, and then divide by 2. And this gives us this midpoint as a coordinate. So this x coordinate again is the middle x point, right? And this is the middle y point, and together they make up the midpoint. Cool. Okay. So why is that useful then in relation to circles? Well, firstly, let's have a look at perpendicular bisectors. With this idea of a midpoint again, let's draw another line there. Let's say the midpoint, not the midpoint, sorry. Oh yeah, the midpoint's in the middle. Cool. But then we can draw what we call a perpendicular bisector, which looks like this. Oh, but it has to pass through the middle. There we are. So the perpendicular bisector is another line that cuts through the middle of a line. Say this is point A and point B. It cuts through the line AB, any given line AB. The middle of that line, a perpendicular bisector cuts through the middle. And what's special about this line is that it cuts through the middle, but also it's perpendicular, so it's at 90 degrees. So the two lines are perpendicular. And what that also means is that this perpendicular bisector, I guess it's kind of in the name, it bisects, which means it splits the left side of the line and the right side of the line equally far apart. Okay. For example, then, if we took the point A here, say if we were to do that distance there to this from point A to that to the top of the bisector, and then we draw from the line B to that same point, those two lines, left side and the right side, will be equal. Okay. So that's the old idea of equally spacing apart the two lines. Okay, so that's the perpendicular bisector. Okay, so the key idea of a perpendicular bisector, I'll label it here, perpendicular bisector, is that it passes through the midpoint of a line, and it is perpendicular to it. Okay, and again, think about how we express two perpendicular lines. We can think of that in terms of their gradients of them being perpendicular, meaning they're negative reciprocals of each other. We looked at that last chapter, but yeah, we can use it here. Okay, so why is this really important to circles? Well, in circles like this, any given general circle, any line we draw inside the circle, say this line here, or that line here inside the circle, or that line there, or this line here, or that line there, or that line there, although it doesn't look like a line, does it? That line there, we'll say this line there. Any line, any straight line we can draw inside a circle is called a chord. Okay. Any at all. Okay. So between any 2 points on the circle, again, say if we have this point over here and this point over here, that line is a chord if it's inside a circle, connecting 2 points outside of it. Say if you have a point here and a point there, that's a chord. Say this point again, I'm going to take it over here. That's a chord, and simply, very simply, a chord is just a line inside a circle, right, that connects 2 points outside of it. Okay, so it's not necessarily a diameter because a diameter passes through the center, but a chord just simply connects 2 points outside the circle. That's simply it. And so why do I bring this up? Well, again, let's get rid of all this. Let me just draw another generic chord, right, on in a circle. Let's say we have this here. Okay, this chord here. Well, what's special is that if we do the midpoint of the chord, the line, right, and then we do the perpendicular bisector, which again is the line that passes through the middle, and it's perpendicular. Well, it turns out that every perpendicular bisector of a chord will always pass through the center, okay, of the circle. So I'll make a note there that for any chord in a circle, that means any perpendicular bisector of a chord goes through the center of the circle, okay. Cool. And actually, what was I going to say? And also, oh yes, sorry. So then, if we have a chord, and then more specifically, what about the diameter of the circle? Now, the diameter of a circle is a particular chord that goes through the center. Okay, again, the perpendicular bisector will go through the middle, so it passes through the center. But what that means is if we have a diameter, then the midpoint of the diameter will be the center of the circle. So I'll make a note of that as well. The midpoint of a diameter passes through the center as well. Okay, so we've got two different ways of basically working at the center of a circle, and the idea of a center of a circle will become very important and helpful for us later on in the course. And you'll see that a circle is defined by its center, so it is very, very paramount that we do work at the center of a circle. But here we just looked at two different ways. So if we have a given chord, we can work out the perpendicular bisector, or we could then, if we're given the diameter, if we're lucky enough, we can then work out the midpoint, because the middle of the diameter is the centre. And you can think of that because the diameter is 2 lots of the radius, where the radius goes between the centre to the outside. So if it's halfway, then it has to be the centre. But yeah, there we are. But we will be primarily using this first point in this section. We will be looking more about chords and perpendicular bisectors later on in the chapter. There's another section for it, but I thought I'd do with that little summary of ideas now. So yeah, that's generally what we're going to be working with in this section, right? So the idea of a midpoint being the average of the two x and the y values for 2 points. And the perpendicular bisector, again, is a line that passes through the midpoint of a line, AB, and is perpendicular to it. Okay, so let's have a look at some examples then. Example 1, we are given the line segment AB, so that's just a line connecting A to B. It's a diameter of a circle where A and B are -3, 8 and 5, 4 respectively. Find the coordinates of the centre of the circle. Okay, so if no, I'll tell you what. let's just kind of roughly plot the point. So minus, let's say -3, 8 is here, and that's A. Then B would be 5, 4. That would be further along. That'd be down here, right? B. Okay. So this line segment connecting A to B, that's the line there. And we are told AB is the diameter of the circle. Now, it wants to find the coordinates of the centre of the circle. So, that means if it's the diameter, the midpoint is the centre, okay? We just described this a second ago. Here, right? The midpoint of the diameter passes through the centre. And we saw it with this little illustration here. That we had a diameter, and the midpoint of that happened to also be the centre. Okay. Cool. So there we are. So we could just take the midpoint then. So how do we work at the midpoint of -3,854? Well, the midpoint is adding both the x values first. So 5 add -3 would be 5 minus 3 over 2. Then we have to add all the y values together. That'd be 4 plus 8 over 2, because there's two y values we're dealing with here. So the average of those will, if we work this out, 5 minus 3 is 2 over 2. 4 plus 8 is 12 over 2, which goes to 1, 6. And that is our centre as a coordinate. Okay, cool. And what's interesting here is, in GCSE, you're only used to the centre of a circle being at the origin, like here, for instance. Although that's a bit off. I'll draw it a tad bit better if I can. There we go, it's a bit better. But actually, here, the centre is away from the origin. And so we will be looking at in this chapter circles that can be centred anywhere on the axis, not just at the centre, not just at the origin. Which again is why this is important to make us have different ways of dealing with that. Okay, cool. Example 2, we're given the line segment PQ is a diameter of a circle, centre 2 minus 2, given that P is 8 minus 5, find the coordinates of Q. Again, let's try and draw a rough sketch. So let's say PQ, so we have P here, and we're given P is 8 minus 5. Q, we're not given Q, so I'm just going to draw it down here. Say, we don't know what Q is, but we are told that PQ is a diameter of a circle, and its centre is 2 minus 2. Well, that means that the midpoint is 2 minus 2, right? Because it's a diameter, the middle of the diameter, which should be here, is the midpoint, but also the centre. Okay. So that's 2 minus 2. So now we need to find Q. So actually we're kind of working backwards in this case. Okay, so we have a midpoint. If we call Q, then point XY, again, just a general XY coordinate. We need to find X and Y to find the coordinates of Q. But we know the midpoint's 2 minus 2. So let's just do a midpoint normally. You know, let's just use X and Y. Let's use a bit of algebra, but let's do it how we normally would, right? Okay, so the midpoint then would be, in this case, if we add the P and the Q coordinates. So if Q's XY, say there, the midpoint would be equal to adding the X and the Y values of P and Q. So X for Q, add 8 for P. Then, like with the, we can do the same for the over 2, sorry. Then over y, that'd be y for q, and then add -5, that'd be -5, over 2, okay? We can't do anything more to that. However, we also know the midpoint here is we're told to be 2 minus 2. Remember, the centre, the circle, because it's diameter, the middle of the diameter will also be the midpoint, which should be the centre of the circle. So then, okay, well then these two coordinates must be the same because they're the same thing. They're both the midpoint. So that means we can equate the x parts together. So x plus 8 over 2 has to equal 2. Therefore, with times across by 2, we get x plus 8 is 4. Then if I subtract 8, I get x is -4. Cool. Then I could do the same for the y coordinates. So this y part has to equal -2. So y minus 5 over 2 equals -2. Times across by 2, I get y minus 5 is -4. Then if I add 5 to both sides, I get +1. Okay. Therefore, the coordinate q now is xy. That's -4, 1. Cool. So yeah, so we can work. So we can work backwards there, and we're given a midpoint. We can work out a missing coordinate, and the idea is not freak out, but we do exactly the same thing as you'd expect. But don't be afraid to use a bit of algebra, right? To substitute in an unknown value, but the process is the same. Okay, the idea of finding the midpoint. Okay, cool. Okay, let's practice this again. We got another example here. We're given the points V -4 2A and W 3B -4 lie in the circle with centre B 2A. The line segment VW, so the line between V and W, is the diameter of the circle. So again, let's draw a rough little diagram. So we have V, which was -4 2A, and then we have Q, which was W, sorry, which was 3B -4. So I've just these 2 points there. It might not be the right. I'm not exactly worried at the point about actually plotting the points accurately. Like, I'm not worried about where the x value would be. I'm just trying to draw a generic line. Okay. But it doesn't really matter. Okay, so we have that sort of sketch, and we also know that this is VW. The line is a diameter, so that means the midpoint again is the center. So the midpoint here of this line is B2A. Okay, so we're going to do the same thing then. So we have these missing values in our points, but we know the midpoint. So that means we can say that if the midpoint is given to be B2A, well, we can also work out an expression for the midpoint by taking the average of the 2 points, right? So then firstly we can add the two x coordinates together at the ends. So V -4, add W, which is 3B, over 2. Then we can add the y part, so 2A for V, and then -4 for W, and that'd be over 2 as well. So that's just using that formula. We again, the formula we stated up here, the general formula for midpoint. Okay, cool. So then, well, again, we're going to do the same thing now. So these two have to be exactly the same. They're the same points. So therefore, we can equate the x part together. So that means B is equal to -4 plus 3B over 2. Okay, well then we can solve that for B. If I times across by 2, I get 2B is -4 plus 3B. Then I'm going to bring the B's together. So I'm going to have... I'm going to bring the 3B over here to get the 2B minus 3B is -B is -4. Then I can just flip the signs to get B is +4. Cool. Then I could do the same for the y part. So 2A is now equal to the other y part, which is 2A -4 over 2. Do the same thing. Times across by 2. I get 4A is 2A -4. Then I can move the 2A to the other side to get 2A is equal to -4. Therefore, A is -2. There we are. So we found the values of A and B there. Great stuff. So hopefully you see what we're doing now, right? We're just applying the midpoint formula and applying the fact that a diameter, again, of a circle. We have a diameter that, by definition, passes through the centre in the middle of it, which allows me to deal with the midpoint there. Okay, cool. Okay, let's have a look at some perpendicular bisectors then, by extending this idea. So you have a line segment AB is a diameter of a circle C, where A and B are -1, 4 and 5, 2 respectively. The line L passes through C and is perpendicular to AB. Find the equation of L. Okay, so there's a bit going on there. So again, let's just kind of have a rough diagram of what's going on. Good idea. With this section, particularly with circles, you should pretty much always draw a diagram to help you to visualize what's going on. So we have A and B, which are these points. So let's draw AB, and then draw the line. connecting them. So we've got the line AB. Now, AB again is the diameter of a circle. So the centre is going to be the midpoint again, okay? Now, I don't know what the centre is, so I'm going to just call it M for midpoint, okay? No, C, right? I could call it C or M, it doesn't really matter. C is the centre, but I could call it the midpoint, either or. Okay, so the midpoint is there in the middle. Now, it says the lines L passes through C, so again, the centre or the middle, and is perpendicular to AB. Okay, so it passes. So if it passes through the line and it's perpendicular, so it's going to be at a right angle to the line there. Okay, so when it meets the center, it's going to be at a right angle. Okay, there we are. But I'll just leave that there then. There we are. So that's the line L. Okay. Right, yeah, so that's what we're dealing with. I need to find the equation of L. Right, again, firstly, think about the last chapter. An equation of any line is y is mx plus c. So now we need to find m and c, the gradient and the y-intercept. Okay. Well, what do we know about the line? Well, firstly, the line L is perpendicular to AB. Well, I can consider then the gradient of AB. I'm going to call MAB, meaning M the gradient of the line AB. So then we can work that out because we know the 2 points, 1 minus 1 4 and 5 2. I can work out the gradient of it by doing changing y, changing x. Right, we did that last last section with lines. So let's do that then. So firstly, let's take B first. The y value of B is 2. Take away the y in A will be minus 4. Then do the same again for x. We have 5 from B. Then take away the x value of A is minus 1. So take away minus 1. That would get me, if I work that out, 2 minus 4 is minus 2. 5 minus minus 1, remember it's a plus because we've got a double negative. So that'd be 6. 5 add 1. So that'll go to minus a third. Okay, cool. So that's the gradient of AB. So L, so that means that therefore, the gradient of L is going to be the negative reciprocal because 2 lines are perpendicular if their gradients are negative reciprocals of each of another. So let's do the negative of this. Well, negative of negative a third is positive because again we get 2 negatives. So it's positive. Then we do the reciprocal. So 1 over 3 flips to 3 over 1. So that's just 3. Okay, so we get positive 3 as our gradient there. And remember, you can always check your answer with perpendicular gradients because if we times minus a third times 3, you should always get minus 1. And indeed we do if we do that times in there. So every 2 parallel perpendicular lines, sorry, the gradient should be true if you get minus 1 if you times them together, which we do here. Cool. So that's a gradient, so we can start to fill in our equation of the line. So y is now 3x plus c, where m's our gradient, remember. So now we need to find c. Well, to find that, we need a point on the line to substitute into it. But I know that c is a point on the line, the centre. But I don't know what the centre is, but I know it's the midpoint, right? I can work out the midpoint between A and B. I know how to work that out. I worked that out just right a few minutes ago. Well, the midpoint then again is you add the two x values A and B together. So let's do minus 1 add 5, and that'd be all over 2. So take the average. Then we add the y values together. So 4 plus 2 again over 2 there. Then we can work that out to get 5 minus 1 is 4 over 2. That'd be 2. 4 plus 2 is 6 over 2. That'd be 3. That's our midpoint, but therefore our centre is 2, 3. So we can fill that into 2, 3. Well, now we know this point then also lies on the line L. We can substitute then this point into L, right? Into our equation for L here. So if we do that then, we get, well, y would be 3. So 3x would be then 3 of 2 plus c. then that means 3 is equal to 6 plus c. Therefore, c, if you take away 6 to both sides, will be minus 3. Therefore, we've got our equation for y is 3x minus 3. There we are. There we are. Good. Good stuff there. There we are. Cool. So that's the perpendicular bisector, by the way, as well. The fact that it passes through the centre and it's perpendicular. But there we are. Okay, let's have a look at another example. The point x has coordinate 7 minus 2 and point y has the coordinates 4q. The perpendicular bisector, so the perpendicular bisector xy has the equation y is 4x plus b, probably worth noting. Find the values of q and b. Okay, so again, let's draw what's going on. So point x, we have a point x and a point y. We need to consider them together, so connected. We need to consider the line xy. So we have the point x there, and say y again would be down here somewhere. So y would be at y, the coordinate is 4q, and x is 7 minus 2. Again, I'm not worried particularly exactly about how correct my orientation of the line is, like if it's in the right axis or whatever. I'll just draw a generic line again and connecting the points together. Just help me visualise what's going on. So we have those 2 points on the line. Well, again, we're given the perpendicular bisector again, which it's going to go through the middle. I'm going to call that the midpoint M, and it's perpendicular because it's a perpendicular bisector. So again, you can help. The name helps. The perpendicular means it's at a right angle, so it's perpendicular to it. Bisector, so it splits it equally, so it has to be in the midpoint. But yeah, there we are. So we're told this bisector then that it has this equation here. Okay. Well, let's work with what we can. What can we work with? Well. There's probably multiple different ways we can do it in the order we can do it. I think potentially this idea of it being perpendicular is staring at me. I think because why? I have this equation is in the form y is mx plus c. They're giving us quite kindly 4 for the gradient here. So that means 4 is the gradient of the perpendicular bisector, right? So the gradient of the perpendicular bisector is 4, okay? Well, then we can use that to work out the gradient of the line xy. So that means the gradient of xy, mxy, because it's perpendicular, that means it has to be the negative reciprocal again, right? So negative, and then flip it, well, 4 will go to a 4th, okay? Remember, that's just 4 is like saying 4 over 1. Then you can flip the fraction to be 1 over 4. And there we are. We get this negative reciprocal to be the gradient of the line xy. But we can also work out the gradient by just computing the, the change in y, change in x, because we've got the 2 points. We can then also say that mxy is change in y, change in x. So let's do well, that's a bit confusing because x, y are the points called it as well. Okay, but let's do this point here then, the big y. Well, the y coordinate of that is q, and then take away the other y coordinate is minus 2. Then we have the x coordinate would be 4, take away the other x coordinate 7. Okay, then we can work with that to then get q plus 2, because we have a double negative, over 4 minus 7 is minus 3. Okay, okay, but we know that, okay, these, we've got 2 expressions for the gradient of xy here and here, right? Well, that means they have to be equal to each other because they're the same, right? Therefore, we can say that q plus 2 over minus 3 is equal to minus 1 over 4. But now this is a sort of algebraic fraction. We can cross multiply to solve it. So if I do, well, first I can get rid of the negatives, right, on both sides. So q plus 2 over 3 is equal to 1 over 4. If I've got 2 negatives on either side, I can just divide through by minus 1 to get rid of both negatives on either side. Okay, well then I'm going to cross multiply. So I'm going to do 4 lots of q plus 2 is equal to 3 lots of 1. Cross multiply on the meaning I'm doing this, okay? Sometimes in the opposites of each fraction together, right? So the numerator on one side by the denominator of the other, okay? But we'll just net GCC. But anyway, we get this equation. Therefore, we can expand the brackets to 4q plus 8 is equal to 3. Therefore, 4q is minus 5. Then q is minus 5 over 4. Cool. So now we got q. That's great. Now we need to find b. Now b is here. It's in this line here. Right. But again, if I'm going to find a missing value in here, I need to substitute a point into this line here. And remember, this line is it's the bisector, okay? So I need a point on the bisector, which is here, right? Well, I do know a point. Again, it's going to be the midpoint. You know, I should always be looking out for a midpoint when dealing with bisectors, okay? So the midpoint of xy, again, now we know what q is. Actually, q, we can fill this in as, what was it? Minus 5 over 4. So now we can work out the midpoint by doing the average of the x and the y on the x coordinates. So let's then add up the two x coordinates on x and y. So we have 4 plus the other x coordinate of 7, and that'd be all over 2. Then we're going to do minus 5 over 4, add minus 2, all over 2. Okay, and then if we, then we can work that out, simplify it. So then we get 4 plus 7 over 2 is 11 over 2. And then minus 5 over 4, and it is probably a lot better to do that on a calculator. Minus 5 over 4 minus 2 all over 2 gets me minus 13 over 8. Okay, so that's my midpoint. Okay, so now I know this point, again, M, has to lie on this perpendicular bisector. So now I can substitute it into here. Okay, so then I'm going to say sub midpoint into the line into y is 4x plus b. Okay, remember that again, that's the equation of the bisector given to us. Okay, well then that means y is minus 13 over 8. That's going to equal 4x, so 4 lots of 11 over 2 plus b. If we work that out, we get minus 13 over 8. Well, that's going to be 22, I believe. Yep. Okay, well then b is minus 13 over 8, take away 22. So if we work that out, I should get that b is minus 189 over 5. Over 8, sorry. There we are. So we've got our values of q then and b. Great. Cool. So hopefully it's starting to make sense now, the idea of bisectors, the fact that they're perpendicular and they're through the midpoint, and we can use that to solve missing values again. But yeah. Okay, let's have a look at this problem then. The points A and B with coordinates minus 1, 9, minus 1, minus 9, and 7, minus 5 lies on the circle C, which has the centre 1, minus 3. Again, let's draw what's going on. So let's draw our points A and B here. Again, A is minus 1, minus 9, and we have B down here, perhaps that's 7, minus 5. Again, a rough sketch of a line. Probably not accurate, but that doesn't matter in this particular case. So it says fine. So we have these 2 points. Okay, it lies on a circle, these 2 points, with a centre 1 minus 3. But we don't need that at the moment because all it's asking us for part A is to find the equation of the perpendicular bisector of AB, where we've just drawn AB. Okay, then the perpendicular bisector, again, is going to look like that. Okay. Well, again, we have a midpoint, okay, in the middle. Okay. So we can probably, it's better to work at the midpoint first, right? So the midpoint is going to be changing the average of the x and the y values. So firstly the x, 7, add -1 over 2. Then we do 5, -5, sorry, that is a -5. Minus -9 over 2, and that will go to 7 minus 1 is 6 over 2, that'd be 3, -5, and that'd be a double negative, a plus, -5 plus 9, that'd be 4 over 2, that'd be 2. Okay, so that's our midpoint, so we can say that's 3, 2. Okay, well then we need to, we know a point on the line, but we need, well, okay, so our equation is going to be y mx plus c, again that's every straight line, but we need the gradient, but we know it's perpendicular to the line, so if we find the line AB, the gradient of AB, MAB, which we can work out, then we can do the negative reciprocal. So the gradient between A and B, again, let's do change in y, change in x. So firstly at B, -5 for y, take away -9. Then we do change in x, so that's 7, take away -1. Okay. My apology. Oh, my apologies here. No, this shouldn't be a double negative. It's -5 add -9, so it should just be -5 minus 9. Which would be for the midpoint. Sorry, -5 minus 9 would be -14 over 2. That'd be -7. Okay, which makes sense. Yes, because we have -9 here, and it's -5, so it should be the midpoint should be in between -9 and -5. Okay, there. Cool. My apologies there. But okay, so let's go back to the gradient then. So again, we have two double negatives, so we have a plus here and the plus here, which helps us to calculate it. So we have -5 add 9, that would now be 9 positive 4. Then we have 7 add 1, which is 8. 4 over 8 will go to a half. Okay. Therefore, we can say that the gradient of a bit of the perpendicular bisector is going to equal, it's going to be the negative reciprocal. So negative, and then the flipping 1 over 2 will then be 2 over 1, but that's just 2, so we get -2. Therefore, we could say that y is mx plus c becomes y is -2x plus c. Okay, but then we just need to find c, but we need a point, but we know what a point is. That's the midpoint that we've just worked out, right? That I had to correct, but we've just worked it out correctly now, which is here, right? So that means we can sub that point in, 3 minus 7, into this equation. Therefore, y would be -7. So then we go to -2, lots of x, which is 3, plus c. And then we can work that out. So -7 is -6 plus c. Therefore, if you add 6 to both sides, c is 1. Which means that our equation is that y is -2x plus 1. There we are. So that's the equation of the perpendicular bisector. Then for part B, it says, show that the perpendicular bisector AB passes through the centre of a circle. So again, AB is a chord, right? Or could be a diameter. But because A and B, say here, point A is here, saying point B is here, it's a chord because it's a line that's in a circle. Because remember, it's telling us that these 2 points lie on the circle. So the line connecting these 2 points has to be a chord because it's a line inside a circle. We know we should expect that the perpendicular bisector will always go through the centre, but we're just showing that, okay? But I'm just saying we should expect that to happen anyway. Okay, part B then. We need to show that the centre, no, the bisector passes through the centre. Okay, well that's where this comes in then. The centre is 1 minus 3. To check that the line passes through the centre, which we worked out the equation, we can just substitute the centre in and it should work. So I'm going to say sub 1 minus 3 into y is minus 2x plus 1. Therefore y is minus 3, so then minus 2x will be minus 2 lots of 1 plus 1, which should get me minus 3 is minus 2 plus 1 is minus 1. Oh, have we gone wrong? Ah, here, c is minus 1. I don't know why I'm making silly mistakes here. So, no, sorry, my equation is minus 2 minus 1. Because, yes, because that's, okay. Because I add 6, but minus 7 add 6 is minus 1. Okay, so I corrected that, which means that this will be minus 2x minus 1. So then I get minus 2 there we go. Okay, so we'll work that out. Minus 3 equals minus 2 minus 1. That's minus 3. There we go. We know that's true. So 1, 3 must be on the line. So therefore, the point 1, 3 must be on the line. So, perpendicular bisector passes through the centre, because the perpendicular bisector again is this line here, and the centre was this point here, and the point satisfies the equation of the line, which means the point must be on the line. Cool, there we are, finally. Had some little hiccups there, but we got there in the end. But okay, that aside, hopefully that starts to make sense now with what we're doing. With the whole idea of perpendicular bisectors, being through the middle, computing the midpoint, and finding the gradients because it's perpendicular, and so on. Okay, cool. I want to finish off with this final question, which is a bit of a challenge question. But let's have a look. We are told that a circle with diameter 10 centimeters contains a chord AB. The points A and B have coordinates 3, 4 and 4, minus 3 respectively. The point C with coordinate minus 3, 4 also lies on the circle. Show algebraically that the centre of the circle C is 0, 0 at the origin. Okay, so again, as usual, we got a chord AB, so let's consider the line AB. So let's draw our points A and B, which is 3, 4, and B, which is 4 minus 3. And it's telling us again about a perpendicular bisect. No, it doesn't. But obviously we are going to work with that. Why are we going to consider the perpendicular bisector of AB? Because AB is a chord, again, it's in a circle. Again, it might look... A chord might look like that. That might be point A and B, for instance, in a circle. If we consider, remember, every perpendicular bisector of a chord, so the bisector perhaps look like that, has to pass through the centre. And we want to show something about the centre of the circle. So it's very helpful here that we must consider the centre, the perpendicular bisector in this case, okay? So that's what we're going to do then. Again, so that will have a midpoint M. So again, we're going to do our usual stuff. So firstly, we want to consider the midpoint between A and B. So we add the 2x coordinates. First we get 4, add 3 over 2. Then we add the y values. We get minus 3 plus 4 over 2. If I do that, that would get me 7 over 2. Minus 3 add 4 will be 1 over 2. And there we are. So that's our midpoint. Then we need to consider the gradients because they're perpendicular. So firstly, the gradient between A and B, so MAB, that's changing y, changing x. So firstly, the y at B is minus 3. Take away the y at A is minus 4. Then we do change in x, so 4 for B. Take away 3 at A. that goes to -3 -4 is -7. 4 minus 3 is 1, so it's just simply -7. Okay, so if that gradient of AB is -7, that means the gradient of the perpendicular bisector is equal to, well, the negative reciprocal, right? So negative of negative a 7, so that's positive then. 2 negatives make positive. Then flip a 7 will be 1/7. Okay, that's reciprocal. Cool. So therefore, equation of the gradient, so bisector, sorry. So the perpendicular bisector is the equation y is mx plus c. That's a general equation of a line. But we know the gradient, right? Y is a 7th x plus c. Then we need to find c, but we know the midpoint again here will pass through the bisector here. The point M will be on that line. So therefore I'm going to say sub the midpoint in, so sub 7 over 2, 1 over 2 into the line. So we're going to get y, which is a half, is equal to a 7th of 7 over 2 plus c. Therefore, simplify that, I get half is, that'll be a 7th times 7 over 2. If you work that out, that should get me a half, right? Half plus c. Yep, so therefore we can say c is 0, alright, if we just subtract a half. Therefore, our equation is y is equal to a 7th x plus, well, plus 0, so it's just a 7th x. There we are. Cool. Okay, so I found the equation of the bisector. That should surely help us. Right. So I'll write that here. Y is a 7th x. Now, as we discussed, this perpendicular bisector must pass through the centre. Okay. So the centre again, we're trying to prove it's 0, 0. So we can't just assume it's 0. We need to, well, firstly, let's just say the centre is a point xy, right? We don't know what the x or y coordinate is, so let's just say it's xy. However, we know that the centre must be on this perpendicular bisector here, right? No, actually, yes, it must be on this centre here. But actually, we're given. Hang on a second. Yes, it's on the centre here. But we know a point C also lies on the line here. On the circle, sorry. Say C's here, again, a rough sketch. What if now we draw another what if we draw another chord between B and C? Or A and B. What if we consider another chord instead between, let's say, A and C now? So we did A and B. Now let's do A and C, because C also lies on the circle, right? So that means if we connect either A or B, so let's do A, to C now, then if we do the perpendicular bisector, that will give me another line that passes through the centre. So if we do this chord here, then the bisector the two bisectors will intersect indeed at the centre there. But yeah, so now we've got another what's it called, perpendicular bisector we can work out. Okay. So again, A has the point what's it called, 3, 4, and C has the point -3, 4. Okay. So again, with this now, that have a new midpoint. I'm going to call this midpoint N. Okay, because the other one's M, so I need to use a different letter. So let's do N then. So firstly, I'm going to find the midpoint again. So that's going to be all the x values together, so minus 3 add 3 over 2. Then we're going to get add the y values together, so 4 add 4 there over 2. That will go down to minus 3 add 3 will be 0, so that'd be 0. Then 4 add 4 over 2 is 8 over 2, which would be 4. Okay. Cool. Right, so that's the midpoint. But then to find this other perpendicular bisector here, so that again perpendicular, so it'd be at a right angle to the line AC, the chord AC. So then let's consider the gradient between A and C, because then it is perpendicular. Again, that's changing y, changing x. So let's do y first. So that's 4. Take away the other y value of 4. All over changing x. That's minus 3. Take away the other x value of minus 3. So that'd be 4 minus 4 is 0 over minus 6. That goes to 0. Okay, cool. Therefore, then, well, if the gradient, that's we're not in the best position here because, well, actually, no, think about it. This is a MAC. Actually, that tells you that the gradient is flat. Okay, if it's 0, it's a completely flat line. It's not going up at all. There's no steepness to it. Therefore, the bisector, if it's perpendicular, is going to be vertical, isn't it? So that means how would we would have to bear in mind it's a vertical line then, essentially. So how would we express that? Well, we know the equation of this one has to be mx plus c. But if it's a vertical line, that's just y equals some number k, right? Remember that a vertical line has an equation like that. So instead, it's just y equal to some number c, okay, in this case. But I'm going to call it k because I used c over here. Again, use different letters. So I'm going to call it k. So because the perpendicular bisector must be a completely vertical line, because the gradient of AC here, if it's 0, it's a completely flat horizontal line. So the perpendicular line to it must be vertical, which means it's a vertical line. So it's just no, it'd be x equals something, wouldn't it? Sorry. There we are. So x would equal something. That would be the line of the bisector. Okay, the perpendicular bisector. But then what is this number k? Well, then we need a point again. That's where this midpoint comes into play. Well, again, the midpoint here would be n again. The midpoint is at 0, 4, as we worked out. Well, x would be 4, right? No, x would be 0, okay? So x would be 0. That is the equation of the perpendicular bisector in that case, okay? Okay, so what do we have here then? Okay, it's quite a weird example that is, isn't it? But yeah, hopefully that made sense in this bit, right? The gradient being 0 means it's horizontal here, AC, a completely horizontal line. So the perpendicular bisector would be a completely vertical line. And any vertical line, think about it. If we draw an XY axis, it's just x equals some number, okay, where it crosses the x-axis, and that's what the number. And then this number x is k. I substituted to find that particular k by substituting this point 0, 4, because that's the midpoint. And remember, the midpoint of the bisector goes through the midpoint still. So I substitute x4 into x is k, but then the x coordinate 0, okay. So that means x would be 0, and that's my equation of the line of the bisector. Now, what we've got now is two lines, the centre, right? Every perpendicular bisector of a chord has to pass through the centre. That means that when these two bisectors here and here that I've just worked out, these two bisector equations that I've highlighted that we worked out, they must intersect, and what their intersection is must be the centre of the circle, okay? Because all bisectors must pass through the centre, which will be the same point, okay? So then we solve them simultaneously then. So y is the 7th x, but also x is 0. Okay, when x is 0, therefore y is the 7th of 0. So it's 0. So centre of circle therefore must be, if x is 0, y 0, which is the origin. Well, there we are then, we proved it. The centre is indeed 0, 0. There we are. Cool. There we are. And I should say centre of the circle as it's the point of intersection. You don't have to write this, but I'm just trying to explain it very fully, as detailed as possible. So it's the point of intersection between the two perpendicular bisectors. Okay, because that's effectively what's going on. Okay, cool. There we are then. Got there. Okay. Quite a hard example there, but hopefully you followed through. And yeah, if you are stuck, hopefully go through it step by step, and it starts to make sense. Quite a tricky example that is, but I think it's a good one. But yeah, so that's essentially that's midpoints and bisectors. So as a recap, you should know what the midpoint is. So that's x1 add x2 over 2, y1 add y2 over 2. So you add the x and y coordinates and divide it by 2 to get the average. It's actually MP, midpoint. Then the bisector, so if you have a line AB or a line, then the bisector passes through the middle, so that's the midpoint, and it's perpendicular. So we can consider the gradients. And in particular with a circle, a chord is any line that goes through that's in the circle that connects 2 points on it. And every perpendicular bisector, say of this chord here, must pass through the centre on its line. Therefore, in this particular last question, if we had another chord, say here, then the perpendicular bisector again, so here and here, the two bisectors, indeed the two bisectors pass through the same point at the centre. Okay, there we are. So that's what we've done. So that's that section, but I'll see you next time.